We just want to firstly say thank you for the reception to episode 1. We've been really overwhelmed. Today we're going to be busting some myths behind robots, and to do that we're welcoming Sam Watson-Jones from the Small Robot Company, and we're going to be having a chat about whether robots really are going to be creating our food.
Plus we're giving away 2 free tickets to an amazing event called New Scientist Live, which is all about careers, innovations, technology. So if you are a computer science student, coder, engineer, or just want to broaden your careers and experience, it's definitely something to look at. So check it out on social media.
Thanks for joining us today, Sam, to talk about the Small Robot Company. It's really great to have you on board.
Thank you for having me, Lizzie.
No, it's brilliant. So, okay, let's jump straight into it. When I think about robots and robotics, I don't know, maybe I'm stupid in this, but I always have this image of like human-like machines, you know, that are packing, driving tractors, a bit like iRobot, I guess. But we've had a look at your products and your photos, and if I'm honest, I think there's something that looks like that they could be sent up to Mars. Really interesting. So of course they're not going on a space mission, but since I'm from a non-farming background and we do have quite a lot of listeners who aren't either, tell me, who are Tom and Wilma?
Well, so Tom and Wilma are two of eventually what we're hoping is going to be 4 offerings for farmers and more broadly in the agriculture space. So Tom is a robot. Tom is a scanning robot, and he goes out into a field, and essentially what he's doing is digitizing the field. So he's taking, initially it's lots and lots of images, and to visualize what Tom looks like, Tom at the moment is sort of quad bike size, I suppose, but he's got an array of cameras on the front that are just taking thousands and thousands of images of the crops that we're traveling over, because we're focused on arable farming, broadacre farming, and it's taking thousands of images, and then those images are being fed into Wilma, and Wilma is the brains, the boss of the operation. She's in charge, and she is a software interface, and she's also a bundle of AI algorithms. So she is looking at the data that Tom is sending through and interpreting it and starting to draw conclusions from that data that we can then turn into advice for farmers, growers, people who are using our technology. And then they're intended to be the first parts. So those 2 things are commercially available today, only on a small number of farms initially, but then they're intended to be the first part of what we're hoping is going to be a transformation into a new way of farming that we call per plant farming. And to achieve per plant farming, you need 2 things. You need per plant intelligence, which is really the bit I've just described with Tom and Wilma, and that's this ability to understand exactly where every single plant in a field is. So if the listeners can visualize a field of wheat, you know, there are millions and millions of plants in a field of wheat. We want to be able to understand exactly where every single plant is, and then we want to draw different data points from those plants. So we want to know exactly the location is one data point, but also we want to know what is that plant. Firstly, is it actually a wheat plant or is it a weed? That's another data point. Does it have any disease issues? Does it have any nutrient issues? Does it have any pest issues? And we want to get that data right at this per plant level. And then the next step is, okay, well, what do we do with that? And the ultimate goal is to get towards per plant action. So we're envisaging this as two more robots, Dick and Harry, we call them, to give the Tom, Dick and Harry the full set. And Dick is a crop care robot, so he's micro spraying, just dosing individual plants just with what they need. So getting away from the broad brush application of fertilizers and chemicals, and also non-chemical weeding. So identifying an individual weed and zapping that weed. And what we're experimenting with at the moment is electrical weeding. So trying to get away from using herbicides away from using herbicides completely. And then Harry will be a precision planter, so placing individual seeds in the ground and varying the seed spacing and the seed depth based on an AI understanding of the soil. And so to get there, obviously we need soil monitoring capabilities on Tom. So there's a lot more development that is going to happen. And there's also, and maybe we'll get into this, there's also an interim that we're working on, because we have this vision of per plant farming. I've been doing this for 4.5 years now, and I came from a farming background. Well, I say came from a farming background. I was managing a farm, managing the family farm for several years before doing this. This is I firmly believe that per plant farming is the way that the world is going, and ultimately it's going to be possible for any farmer growing any crop anywhere in the world on a farm of any size to be able to gather data on every single plant that they are growing and to be able to take action on every single plant that they're growing.
Honestly think that's incredible. Genuinely, I think that's crazy. Like that you can basically farm but with robots. Like, I know this sounds ridiculous, but is it made through like coding? Is it got kind of like a software behind it? Can you how do you control it? Is it on your phone or anything?
Yes, you can control it on your phone. Well, on a tablet at the moment, so you can see what the robot can see. But these robots are autonomous, and you're right that how they're built is we need two sets of skills. So we need engineers, mechanical engineers who are physically putting these things together, and we have a real mix in our team of people who have been through agricultural engineering programs. So they're graduates, and also people who are apprentices with no farming background, who are coming in and learning, learning on the job, and then also experienced engineers who've been working in other parts of the industry for ages, and who again have no farming background. They're one part of it, but then you also need a load of software expertise, coders. You need people to physically put the thing together, but you also need coders to make it work. You need AI experts to build the artificial intelligence algorithms so that the robots can understand what they're looking at. So it's a real range of skills, and we've got 50 people in the company now, and I would say that probably 25-30% have come from a farming background in some form. So either they grew up on a farm like me, or they went to agricultural college. They've got some sort of farming background. The majority of the company does not come from a farming background. And a few years ago, most of them would never have thought that food and farming was going to be something that they were going to be interested in, something they were going to use their skills to look at. But that's what's been exciting, has been engaging people with this vision for this transformation that is happening already in the world of farming, and it's an exciting place to work.
So actually, you would say that for those who are studying any of the topics and subjects that you've mentioned, there's a wealth of opportunities in agriculture, which they may not have considered. As you say, it's easy maybe if you're coming from agricultural engineering or something like that. But there's potentially other industries that might be pushed or considered first before looking at the agricultural robotics sector.
Absolutely. I think that if we think of, unfortunately for many people, when they think about working in food and farming, it's working on a farm can be perceived as dangerous, and the statistics show that unfortunately that is the case. It is one of the most dangerous industries to work in. It can be perceived as dirty. It can be perceived as really hard graft. And some of those things today are true, but actually, I think that that a lot of those things are going to change. I think the good bits about farming, the being outside, the engaging with the environment, the understanding of where our food comes from, all of those things are going to continue. But working in a farming environment is going to become cleaner, safer. It's going to become much more appealing to a much wider and more diverse group of people. And these new technologies that we're talking about and that we're developing are going to be right at the heart of that, because it's not going to be about big machines, and it's not going to be as masculine as it has been in the past, the farming sector, because the machines that we're going to use are going to change, and the way that we're going to do things is going to be more exact. It's going to become much more scientific, and I think much less, dare I say it, much less macho. And I think that's going to be a really interesting transition for farming to go through.
Brilliant. So just out of curiosity, you said that you've got, 20-30% of people are from a farming background in your company, and then the rest are from a non-farming background, and you've got a range of skill sets, apprentices. Do you maybe offer, work experience? Could you offer work experience to maybe one of our listeners, or career days, or just advice about getting into the industry?
Absolutely. So yeah, we do. We offer work experience. We offer placements for students at different levels. So some partway through degree programs. Also, as I said, some apprenticeships. We've got people going through MBQs and things like that, who are working with us, and that is. That's absolutely something that we offer. What I will say is that our expectation of the standard is extremely high, and
Yes.
it's now extremely competitive to get into any of those places. But absolutely, that is something that we have offered for a number of years, and we'll continue to offer, and hopefully expand that program as well.
So if somebody's listening and, they may have a question, or they want to know a bit more about how they could apply for work experience, what's the best way? Is it, would you be happy for them to email through to us? Is it best to directly go to you guys? Do you have something on the website?
So we've got lots of information on the website. There's all sorts of ways to find out about what we're doing. There's loads on YouTube as well. And if you are interested, the best email address is info@smallrobotcompany.com, and the website is smallrobotcompany.com. And so yeah, there's loads to find out about there, and there'll be information about the different roles that are available, of which there are several at the moment, and ways of getting involved.
Fantastic.
I think that's great, and I think perhaps a lot of our listeners will be reassured to think that there are more ways into the industry. As you say, it can be an apprentice way in, or other qualifications to get them, whether it be the small robot company or any kind of other companies in the sector, and that there's different ways in, I think, as I said, is reassuring for them. So you mentioned, your kind of new robots which are coming out. So Dick and Harry, any kind of, are they at trials level yet? Are they out in the field? And when will they be kind of accessible to anyone, your everyday farmer?
Yeah, so as I say, so Tom, the scanning robot is out and offering commercial services today. In fact, I'm just on my way down to see him working on a farm in Hampshire. And then Dick and Harry are going to be released over the next couple of years. We're doing various trials with Dick in particular this year, and we are also looking at integrating the data that Tom is collecting with existing farm machinery. So particularly, we're looking at farm sprayers, variable rate sprayers. We're looking at what our per plant understanding can enable for a sprayer, because many of the best sprayers available on the market today are not used to their full potential at all. And the reason for that is that the data that they are operating on is flawed, gappy, not structured enough, not detailed enough. And that's what the Tom robot gives, is he gives a really structured, detailed data set that enables the technology that already exists to operate in a much more accurate way. So actually, you're going to, that is something that we're hoping to offer to around 100 farmers in the next 12 months or so, and then the more accurate spraying technology that'll be available on Dick will follow on behind that, and then Harry will be following on behind that. So yeah, it's all happening, and the next 2 to 3 years are going to be extremely exciting for us in terms of product releases.
I can't wait. Can we come visit and have a look?
Absolutely. We're just moving to a bigger premises, and we'll be on a farm at Porton Down, and we're going to have our own R&D field and our own trial site. So yeah, absolutely, we're going to be holding demonstrations and really looking forward to welcoming people and showing them the progress that they're making.
Fab, should we go back?
Yeah, I'll book it in. So in terms of your robots, you mentioned, I guess you're offering them as a service, but obviously that still requires, investment effectively to kind of access all the data that they gather. But how do you show that for potential customers, this data really is worth it and it helps your management decisions? Because I know from our experience at home, we actually do use kind of the field scanning and gathering data already. But the only reason that it's effective is because we use the data to then inform our actions. And not everybody does that. And in that case, it looks like a very expensive thing to do. So how do you get across the message that the data is worthwhile almost?
Yeah, well, it's two things really. Firstly, it is the effectiveness of the artificial intelligence that we're able to bring to bear on our data sets, and we're able to do a lot more with our data sets than existing comparable data sets, because we've just got a much greater volume and a much greater consistency of that data. So therefore, artificial intelligence can detect things from our data sets that it can't detect from other data sets. So I'll give you an example of that, and it would be around weed control. So at the moment, you might get a drone that can detect weeds. Really, the best technologies that are out there at the moment are doing what's called green on brown. So they're detecting weeds in a stubble, so before the crop is growing. We can do that bit, but the bit that we can do on top of that is we can not only detect, okay, say there's a weed here, and this is how many weeds you've got. We can do that firstly through the growing season, so we can detect green on green effectively. We can see a green weed growing in a green crop of wheat. But then we can also use AI to inform the farmer around whether that is a weed that needs to be eradicated. Because the challenge that we've got at the moment in our farming system is that our method of weed control is something like a human being walks out into a field, sees some weeds and goes, all right, well, I'm seeing these weeds regularly, and I know that these weeds are really dangerous to my crop. They're really competitive, but these weeds over here are much less competitive. But I'm just gonna spray herbicide over the whole field. Well, we can give the farmer an insight in saying, yeah, you've got these weeds here, so you've got black grass over here. That needs to be eradicated. It's highly competitive. You know, there's a zero tolerance for that. But over here, you've got something that's much less competitive, and actually up to a certain population density, it's fine to leave that in place. And then there's another layer that the AI can do that. It can make that, it can inform that decision. And then there's another layer that can say, well, actually, this is the ecological benefit of leaving these weeds in place. So you're not going to leave black grass in place, but there are other things that you might, because they're a food source for invertebrates, or because they're attracting a particular type of pollinator. And so the data that we're gathering is enabling that farmer to make a much more informed decision. And we're doing that over the whole field, and that would be impossible for a drone to collect it, because they're just not they're just not able to get the quality of the image resolution required to do that over a whole field, or rather they can, but they can only do it in a very, very inefficient way with hundreds of battery changes and things like that, and you can't do it with a human being. So we're giving that per plant resolution, but across the whole field. I think that's the first bit is the AI can do more, and then the second bit is that we're actually producing a data set that as I said is going to enable machinery. It's going to enable the action to take place in a much more accurate way than is currently possible. So I'll use the example of the weeding map again. What you might have at the moment is so for example, the John Deere See and Spray will drive out over a stubble, and it will recognize a weed. And as it recognizes that weed, it is sending that information at the front of the sprayer. It's sending that information to the back of the sprayer, and the sprayer is then turning nozzles on and off. So it can do that, but it can only do that at a particular pass in the season before the crop is sown, and it has to operate very, very slowly. Whereas we can do that throughout the season, and the sprayer can operate at full speed because we're taking that data and then sending it through as a shapefile into the sprayer.
I think well, it's a very interesting kind of way of going about things, and as you say, probably the way forward in terms of what you save on applications of any kind of herbicides, etc., which for farmers you would hope would be a no-brainer on both the kind of environmental and financial elements. So that's obviously what it does for the farmer, but as a consumer, what does it mean for them that they're consuming and buying food that has been helped in production with robotics? Does it actually mean that, for example, I don't know, it's got a lower carbon footprint, or they can kind of rest assured that it's more environmentally friendly? Because I guess everything has to be sold to the consumer at the end of the day as well.
Yeah, absolutely. And so, to be clear, in the stage that we're at, we've got a lot to prove in this space. And the next couple of years, at least for us, is all around proving the value of what we're doing for the farmer. But if you look at on a slightly longer term horizon, I absolutely think that there will be a concept of robot grown produce, and the consumer will become more educated about the fact that farmers have the best intentions for how they're going to they're going to produce this food, but they are limited with the tools that they currently have available. As I've said, I've used the term broad brush, which is really what our farm machinery is at the moment. It is not a highly accurate, precise scientific instrument. It is a tool that has been designed to maximize the efficiency of the people hours driving those machines. It's been built to be as fast as possible, not as accurate as possible. But what we're building is a really precise scientific instrument that is then going to lead to huge reduction in the amount of fertilizer required, huge reductions in the amount of chemicals required, much better outcomes in terms of soil health. And we hope, although we have to prove this, an improvement in the quality and the nutritional density of the food that is produced as a result of all of those things. And so over time, absolutely, we want to be part of educating consumers around what robot grown means. And one of the farmers that we're offering a commercial service to is the Waitrose farm down in Hampshire. And this is a conversation that we've had with them. Exactly as you said, this needs to be valuable to consumers. Ultimately, it can't just be about saving production costs for farmers, although that's important. It ultimately needs to deliver value for consumers. And so that is a journey that we're looking forward to going on with them.
I'd almost like to say, from a consumer, perspective, you've got, when you go into a supermarket and you've got labels that kind of show if they're British or if they're free range, etc. It would almost be quite nice to have like maybe a label that shows that it's been robotics if it becomes such
Absolutely,
a big thing. I think that's really exciting.
absolutely, yeah. As I say, I think robot grown will become, or some version of that will become an understood term, and yeah, I'd love to see food labeled like that. Because the other side is, is of course carbon footprint, and people are becoming much more aware of what that means, and I firmly believe that that robots are going to be the way of providing the detailed measurements that we need to have a really detailed understanding of what the carbon footprint of particular food products is. I don't think that without that we can really get there.
Are robots really creating our dinner, and what's the future looking like?
Well, I don't think it's fair to say they're creating our dinner yet, but I think that absolutely it's not something that's in the distant future. It is something that over the next 3 to 5 years is going to become much more commonplace. There are all sorts of small robot companies doing some exciting things, but there are all sorts of companies doing really exciting things in this space, and the the future is going to be led by highly precise scientific instruments. Farming is going to become an exact science, and we think per plant farming is going to be one of the articulations of that. I think it's a really exciting time, as we talked about at the top, for people coming into the industry, for people from all sorts of backgrounds with all sorts of different skills. Because of course we've talked about the technology skills, but there's also business administration skills and operational skills and marketing and sales and all of those things are going to be exciting roles that happen in these new young companies that are coming through and really changing the way that the industry operates. And as we've talked about, I think it is going to become the way that people expect their food to be produced. And that for me is really exciting. I think we're on the cusp of a huge transformation, and it's just going to become what people expect. And actually, once we get there, once we have these highly exact machines going around our countryside and really accelerating a transition that's already happening towards prioritizing soil health, improving the way that we use our water resources, massively reducing the pollution that unfortunately does happen in the industry. Once we have that happening, we will look back at how we used to do things and think it was somewhat ridiculous. It's going to be a technology that's really going to truly transform the world, and we're excited to be playing a small part in that.
Yeah, well, I think, as you say, just a lot to be excited about in the future for everything regarding robotics in agriculture. But our final question, which we do ask all of our guests, is, I guess you're a combination of both office and field-based work. Lizzie and I know whether we're team boots or team heels, but what would you be?
I'm not sure how good I'd be at walking in heels, to be honest, but a lot of my time is more of my time is team heels. I have to say at the moment.
Yes, Sam.
But I do get a bit of team boots time as well. So I'm going to be doing some team boots work this afternoon, and I really like that. I really like that mix.
Fab. Well, thank you so much for joining us today. It's been really, really interesting, and I'm sure our listeners are going to love it.
Well, thank you for the opportunity, and best of luck with the podcast.
Thank you
Very much. So thanks everyone for listening today and joining us. I think you'll agree that's, well, I feel like I've learnt loads, to be honest.
So have I, plenty.
It's going to be interesting to see what the future is going to hold and, well, where we end up with robots.
So yeah, if you'd like to get in touch, please do give us a shout on social media at Boots and Heels UK or email us at bootsandheels@markallengroup.com. Plus, don't forget you can win 2 free tickets to New Scientist Live. Check out our social media for all the rules and entry. And yeah, give us a shout.
Don't forget as well, episode 3 will be out next Saturday. Just keep up to date to find out what we're talking about.
Thanks again for tuning in. I'm Lizzie.
I'm Becca.
And this is Boots and Heels.